engineer at OpNet. So what topics we're going to cover today? We're going to talk briefly about the application performance engineering lifecycle. Then we're going to discuss some of the performance engineering challenges that have been introduced with the modern technology stack and environments that we have to operate in, and the modern process that everybody has adopted. Then we're going to cover a few use cases that are enabled by big data. And at last, we are going to discuss how OpNet specifically tackles some of these big data challenges in performance engineering, and show you a brief demo of one of our key products in that area. So before we jump into the discussion of how we can enable and improve performance engineering with big data, we should spend a little bit of time talking about what big data really is. So you'll probably find a lot of different definitions of big data. It's a new field. It's very exciting to the business, getting insight into various areas of operations, of the business cycle, and so forth. In terms of how I define and how OpNet defines big data, these are some critical factors. So when we talk about big data, what are these properties? One really important thing about big data is not necessarily how big really the data is. It's more about completeness and level of detail that you're receiving from these big data sets. So in other words, I can have terabytes of incomplete data, or I can have gigabytes of complete data. And in this case, I would consider gigabytes of data big data because that gives me a complete insight into a problem. Another factor of big data is accessibility and timeliness. So if we are trying to use the data operationally to gain insight and take actions, it's not sufficient to just have volumes of data. I should be able to have very quick, direct access to the data to make sense out of it and to be able to take action. So another facet of big data is that it's macroscopic and microscopic at the same time. When you say macroscopic, it's really, am I able to see the forest for the trees, and vice versa, can I see the individual trees in a lot of detail? To use a paradigm. If I have only microscopic data, I may be missing high-level patterns of what is happening to a particular object of interest or objects of interest. On the other hand, if I only have microscopic data, I may see the patterns, but I'm not able to then fully understand the reasoning and the factors that are changing the global patterns. So again, important to have both macro and microscopic view into the data. Really, the end goal of big data is not just for us to buy bigger machines and have cooler new technology to be able to play with. It's really the core of it is enabling discovery, exploration, and our insight into a particular set of problems and particular subjects of interest. So again, the key here is completeness, exhaustiveness, and insight into a particular domain. And as a result, based on these requirements, big data has emerged, and it's posing new. It's really challenging us to develop new computing paradigms to be able to handle it. So, after the discussion about what big data is, let's talk specifically about how big data applies to application performance engineering and the life cycle. In a lot of areas, when we say application performance engineering, a lot of the focus falls on QA. Are we doing load tests? Are we passing our service level agreement thresholds? Are we ready to release code? And I would argue that application performance engineering should be really seen as a life cycle where every phase feeds into one another to produce a holistic, well-designed application, well-engineered system to handle the volume for that application, well-designed suite of tests to be able to verify that the application is going to perform well. So really, when you look at it, there's data that's flowing between the dev, the QA, and the prod cycle, and this is application performance data to ensure that at the end we're delivering a good service. And at the end, really, application performance engineering, it's all about delivering a good service. It's not about managing servers. It's not about pushing code. It's not about necessarily troubleshooting. It's really our goal is to deliver something good to our end users and our customers. Current methodology and approach that is not big data enabled has introduced a lot of gaps throughout this life cycle. And we're going to jump into some of the challenges that are really contributing to having these gaps in the overall performance engineering life cycle. So the first challenge, everybody's acutely familiar with this. Applications are getting more and more composite. They're built out of many different parts. A lot of third-party frameworks participate. Now more and more third-party services that are live and providing a data service as a software as a service model. They enhance the dependencies within the application. What that means is that now we have a lot more parts that are participating in just building a single experience for the user. So the complexity of the environment is definitely increasing, and we need to be able to handle more and more performance data in different types, forms, and shapes to be able to really understand the user experience, and then also be able to diagnose down to line of code for a specific third-party component where certain bottlenecks exist. Another performance engineering challenge is that not only is our application environment very complex in terms of how we deliver a service, but now we also have a very big diversity in number of devices out there, in number of clients that are accessing our applications. So this is a slide from Intel that's showing the explosion of variety of clients, of mobile devices, of different types of browsers, of other connected devices, overall understood as the Internet of Things. Now, all these Internet of Things devices really depend on data services that we're delivering. So now it's becoming even more important to be able to collect, store, and analyze and get insight from data, performance engineering data, to really be able to troubleshoot specific areas of the application that are related to this complex client environment. So in summary, not only is the application infrastructure environment more complex, but now we're seeing an explosion in terms of who is connecting to our applications and how they're using it, which poses additional challenges of how we troubleshoot, how we analyze performance. And I didn't mention this, but also our expectations are growing in this environment. So everybody expects that a single page should render within 2 seconds and should be available 24/7 across the globe. Okay, so where is Waldo here? We have our agile development lifecycle, and we're really focused on developing new functionality iteratively, and making sure that our code is stable, it's well designed. We're demoing the features to make sure that we have acceptance early on before we roll out a big change. And then we have continuous integration to make sure that any small changes can be rolled out to production as fast as we can, literally releasing daily, weekly, as opposed to monthly and quarterly and yearly. So the challenge here is, well, we've sped up the development lifecycle and the system integration lifecycle, but what have we done in terms of performance? Has that actually gotten better or worse? In most agile development organizations, one of the first things that suffers is performance. Again, the reason being we're developing at a faster rate, we're delivering features, but our tools are really not suited to help us with this life cycle. So in other words, the performance tools, they require a lot of rigging, a lot of setup, a lot of overhead that's designed more for waterfall type development. Agile development, the tool set and the data that's being collected currently is not sufficient to enable that life cycle to work properly and make sure that we actually do address performance engineering as part of this life cycle. So that's another challenge, the speed, the pace that we're developing is not accounting necessarily for solid performance engineering. Another challenge, of course, we're always running into this, but our development and our production environments are different. So we need to be able to understand how actually things work in production so that with the data that we have better, better assurance that what we're developing in dev will actually work in production. And again, we're not going to be able to have a pristine development environment just like production, but the key aspect here is that if we actually do have the data to model and to understand how production works, chances are that we'll do better in our development environment that's not necessarily mimicking production. And another important point here is even if we actually do mass production and development, it is impossible to actually test every single path of the application. In some cases, we may introduce a production performance issue just by the sheer fact that we didn't test a specific client that's accessing our application, or a specific type of client. So then having the production data, every single transaction all the time, helps us really understand where things are breaking, how, and how we can address them in code. Another challenge in general has been, and it's actually accelerating in terms of importance, is we want to monitor and manage and instrument applications and do performance engineering throughout this entire lifecycle, dev, QA, and production, without actually introducing overhead that would impact the application. So it does us no good if we capture a lot of data and we break the application with overhead. That challenge has always been there, but now that we have more complex environments and we need to collect more data, that's even more important. And last but not least, hopefully, again, we've solved this problem, but we do have scenarios where it is impossible or impractical for a certain environment to be replicated. So we're always going to have unique scenarios where, we have code that's actually maybe third party or something that has been legacy code that is not really well tested in test and ends up in production. Hopefully we've minimized this and it's not a problem, but it is possible that this is still happening. So now we talked about big data. We scoped it out in terms of what big data means. Again, completeness, having an exhaustive data set, delivering insight both at microscopic and microscopic level. We also talked about some of the performance engineering challenges. So really, I do believe that nowadays to effectively be able to bridge these gaps in performance engineering in the life cycle, we actually do need to use a big data approach so that, we can troubleshoot, we can do root cause analysis, we can investigate issues in QA, production, development, have a common set of practices and tools that enable us to do this type of analysis. Again, be able to look at the high-level patterns of how the system and application works, be able to understand how we're delivering a service at every single point of our infrastructure, and understand how that actually contributes to the whole. be able to discover these patterns and be able to act on them. So the buck doesn't stop at us being able to just monitor our infrastructure. We have to understand the end user experience. We have to understand how the actual application operates. So all these points that are listed are big data, are use cases that really enable performance engineering with big data. So some of the examples, again, being able to do analytics, comparative analysis, be able to drill down to line of code once I see that my overall service level agreement has degraded, be able to then share that information with my development team to understand what design changes need to be introduced. Then I need to use the production data that I've captured, make sure that I'm designing good, solid tests when I go into QA, being able to then compare production and development and QA results using the same data, and making sure then that the cycle is complete and make sure that I have confidence that when I roll something out from my staging or QA environment to production, it's going to behave as I expect. At the same time, if I do encounter certain problems in production that we've never been able to successfully test, I do have the capability to quickly diagnose, troubleshoot using both metric, transaction type data, and really minimize the service degradation or downtime by quickly identifying the root cause of problems. So we talked about big data, how it actually enables performance engineering, where it fills some of the gaps. When we say big data, what does it mean from the standpoint of us, of OpenNet? So some of the really important factors here is that with our tools, we strive to give you both the macro and the microscopic view. We're collecting hundreds of thousands of metrics, giving you the analytics to be able to quickly find patterns in the data and be able to really find any, instead of you sifting through really thousands of records, be able to quickly identify where some of these bottlenecks are happening within the application or the system, giving you the code level transaction tracing, which will record every single transaction throughout the runtime of that application, whether it's dev, QA, or production, and then give you the tools to go down to line of code in historical mode and really see if you had a performance degradation 8 o'clock yesterday when when you didn't have necessarily anybody looking at your monitoring tools, be able to go back retroactively, pull those particular transactions that were problematic, inspect the system, see if there's any behavior that has changed, and really drill down to line of code, find any components or application bottlenecks. So mirroring the transaction data, and again, billions of records being kept and stored, all transactions being captured all the time, and giving you the searching, the near real-time access to this data, enables you then very quickly pinpoint the global and the local patterns to find the specific issues. So hopefully we've illustrated why you need big data. Hopefully we've covered some of the approaches that OpenNet has taken. And really, in ideal world, you shouldn't never have to do a performance engineering. In practice, it's really a lot of the success of the business hinges on good service delivery and good performance engineering.